Hello, folks. So today I would like to present my work about AI agent that helps to customize and deploy clusters, Openshift clusters via GitOps. And let's see what we have. So just brief introduction what we are talking about. There is a product is called ACM, Advanced Cluster Management, and it allows you to deploy and customize various cluster under it. And we have right now installed hub cluster. It's called with ACM, and we want to use it for installation various spoke clusters for it. So how it's done via GitOps? Usually we have a cluster configuration in one file. It's a cluster instance object. It's at config v2, and there is a lot of configurations here, nodes configuration, cluster configuration, you see a lot of networking here and so on. So what we do here, and if we want to customize it, we need to go to Prover API Explorer, find this object like cluster instance, open it and trying to find in schema what we would like to do, and it's all nested here, and you need actually to know exactly where you want to go and what exactly you want to change. Without this knowledge, it will be really challenging to do this. And here comes AI agent, and uh, it helps to overcome this challenge by totally handling all customizations, reconfigurations of clusters, and also their deployment. They are deployed via Argo CD. It's an OpenShift GitOps separator. As you see, it's out of sync. So because we have only basic cluster configuration, it's not applied yet. Nothing is installed. And if we go to all clusters, we'll see only the hub clusters here. So this is an introduction. We'll see now how we customize managed clusters and how we can deploy them using only AI agent. All right, so let's start hacking. And we'll start from something simple. Let's ask questions about clusters. And for AI, you need to set a kubeconfig path, of course, because it needs to communicate with cluster, with OpenShift, and to understand, to get information and apply changes. And name of the cluster, because we can manage multiple clusters there. So I asked a very simple question about how many masters I have on the cluster, 3 master nodes, that's great. And you can ask him more questions about configurations and so on. But let's do something more interesting and do some deep changes. For example, let's enable CPU partitioning on all nodes for cluster, and let's see if it handles this, if it understands this. So we can see here the bug messages where it's thinking and making a plan what to do and how. You can track this also in the console, of course. And this is the Git. Here we expect for changes to happen actually. And all right, it tells us it was enabled and it was updated in Git repository. Let's check. Enable CPU partition commit. Well, that's great. And you can see that it not only made it correct with correct keyword and value, it also created quite explanatory commit message about Git and what it did. Cool. That went great. And let's do something more tricky and add NTP server, another NTP server to the cluster. We have already one defined, so it should add it to the list, not just replace or add configuration. And it's a little bit harder to do. Let's refresh. All right, seems like we did something cool. So you can see here NTP servers before that, and it added 10, 10, 10, 10. And yeah, it also posts the messages to the chat. That's great. Okay, and now let's test its history skills. And we want to revert the last change, and we don't tell about the change. So it should understand it from context. Let's see. Let's refresh again. All right. It created revert commit and deleted the previous commit actually. Cool. Last change was successfully reverted and this NTP server was removed. Awesome. And now let's do final thing that we want to, it's deploying the cluster, right? So let's say you understood the idea, we configured things, we removed, added, customized clusters, edit things there, and let's deploy it. So for deploy, we have here totally out of sync repository. What we need to do is actually to trigger the deployment here, and let's see if it worked. Yeah, you can see it's synced and started to deploy. Great. This is worked and cluster deployment has successfully initiated. Awesome. All right, so we started to deploy the cluster and we can see the cluster appears here as draft because it just started to deploy. So we're on the right track. All right, so let's talk a little bit about challenges and conclusions that we had. But before that, let's mention technologies. First is AI model. I used Gemini API. MCP I wrote by myself. It's for OCP and Git to retrieve information, specs, and so on. Agent based on LangChain and web UI of this chat is Gradio. So this is the technologies, actually quite standard for today. And challenges of conclusions and challenges, there were a lot here. First, it's still hallucinations of LLMs, and even models like Gemini still do some hallucinations. They don't write keywords correctly and sometimes add and change things that I never asked them to do. So especially the most hard thing, it's repeating the same information. For example, if you send a private SSH key, it's completely meaningless information, right? It's just sequence of symbols without any meaning. And ask LLM to repeat it is the same. Most likely you will see like some symbols changed. And that's the problem because if you have something like that in the cluster configuration, you're screwed. Everything is broken because one symbol change. A search key will not work with one symbol. It's critical change. You cannot rely on the LLM to repeat such kind of information. And same thing about base encoding, any other encoding actually of data. So this is one of challenges I had to hit here. And if we have long outputs of the model, for example, this very big cluster configuration might take let's see how many lines there. And it's not the biggest one I saw, to be honest. This one is about 240 lines. And if we have something more, the more changes to get some unintended changes that we didn't expect there. And yeah, the LLM is not deterministic. I think you understand this. So what are conclusions and what can be a solution and workaround about this? So firstly, we should ask from model to generate as less as possible output tokens. Not only because output tokens are expensive, but also the more tokens it generates, the more probability for errors and hallucination to happen. For example, if I started from asking the full config of cluster to be changed, I always got something wrong there, something changed that I didn't ask for it. When I moved to use patches, which is much smaller than the whole file configuration, instead of 240 lines, I get 5 lines generated. I actually eliminated this problem, and now it works much better. Still, it might be problem with calculation of which line in diff, but still, it's much more reliable if you get less output tokens and LLM actually generate less things. So the solution here is optimizing actually your workflow to narrow down the output of model and to make it generate as less as possible, and just to seek for other ways to get generated data and as compact as it's possible. And everything that is deterministic and you can do with automation, with scripts, MCP, of course, should be done by them, not by model. For example, of course, LLM can do git commands like git commit and git push and whatever, but it can be that once in 100 times it will do some crappy command and will break everything. And there is no any reason to give to LLM to do such things. If you have something deterministic, just delegate it, write MCP servers, do scripts, and delegate all work that can be done by automation to automation. Actually, the most important conclusion here is to use AI as less as possible, only in the place when it's really uh, it cannot be changed. For example, like working with user and understand user intentions and what they want to do. So that's it, and thanks for your attention.